Welcome to this video on stoichiometry. We won't actually be getting to do any stoichiometry today, but we'll look at formula before we do anything else. Now, you'll probably think, formula are obvious what they are, but they're not actually. There's two types of formula we use in chemistry. Now, one is for ionic compounds. Now, an ionic compound is something that has ionic bonding in, and the other thing we use formula for are covalent compounds. And that means the bonding is covalent. All right, ionic and covalent compounds. Right, let's have a look at an ionic compound first of all. Let's pick a nice simple one. Let's pick sodium chloride. Okay, and if I were to zoom in on a sodium chloride, what would it look like? It would look something like this. Now I'm going to draw this quickly so it doesn't take up too much of anyone's time. Okay, they're one type of ion, and let's do green for the other type. Ooh, there we go. Okay, there's the other type. Okay, and let me try and squeeze in the charges. Let's say these are the sodium ions, these yellow circles. And let's say the green circles, let's have a different color. Let's have a nice purple. All right. And these are, it doesn't come out very well, does it? But these are the chloride ions. So in my little diagram here, this represents a sodium ion. And the green one, oh, I've got rid of it now. The green one here represents a chloride ion. Now, as I said as well, the sodium ones are positively charged, and the chloride ions are negatively charged, aren't they? I can't remember. Did I pick that color? I think. There you go. That's the legend, as it were. Now, as you can imagine, this is what I've drawn here is a two-dimensional structure. This is 2D, isn't it? I can only see one flat surface of it, but it goes back into the third dimension all the way down here, right? It goes back and back and back. All right. So, how many sodium ions are there? How many sodium ions and how many chloride ions are there? Well, even in the tiniest crystal, there's countless millions and trillions of sodium ions and countless millions and trillions of chloride ions in the crystal of an ionic compound, okay? Because this is ionic bonded, and in the crystal there's millions of each. So we can't say Na 8,768,000, Cl 8,768,000. We can't do that. So what we do is instead of quoting the number of sodium ions and the number of chloride ions, what we do is we quote the ratio of sodium ions to chloride ions. So for every one sodium ion, there is one chloride ion. Okay, and therefore we write the formula as Na1 Cl1. We don't put the ones in, but that's what we mean when we say NaCl. Now, this 1 and 1 is the simplest. This is, oh, that's not how you spell simplest. This is the simplest ratio of ions in the compounds. Okay, it's the simplest ratio. All right, and the simplest ratio is given a very special name in chemistry. The simplest ratio, this thing here, is known as an empirical ratio or an empirical formula. So for ionic compounds, we don't quote them as any other thing. These all ionic compounds formula are empirical formula. Empirical. And that means that they show the simplest ratio. Okay, one sodium ion and one chloride ion. Obviously, as well, which we'll perhaps get onto in the next video, sodium chloride, the charges must balance. So the formula of the compounds, this guy here, must be neutral. Okay, how is it neutral? Well, 1 plus and 1 minus makes it neutral. So the ratio must be 1 to 1. If I looked at something like magnesium, which has a charge of 2 plus. Chloride has a charge of 1 plus. To make this neutral, I'd need 2 chloride ions. I'd need 2 of these for every one of these. And therefore, the formula of magnesium chloride must therefore be MgCl2. But it's still an empirical formula. It's still the simplest ratio. So for every 1 magnesium ion, I need 2 chloride ions. Okay? So that's ionic compounds, and that's empirical formula. What about covalent compounds? Well, covalent compounds use something called a molecular formula. Okay, this is a molecular formula. And that just simply states what is in the molecule. So, for example, a simple sugar, let me see, what's the simple sugar? Glucose. Glucose is C6H12O6. Okay. Now, we could quote an empirical formula for sugar. What's the empirical formula for glucose? Sorry. It would be H2O, wouldn't it? But this would be the empirical formula for glucose. The actual formula, what's in the actual molecule, is C6s. That's what I'm talking about. 6Cs, 12Hs, and O6. Now, if you look at a glucose molecule, it's a hexagon-shaped thing. That's where the 6 carbons come in, and we have OHs on all of these. Okay, so that's where the 6 O's come in. Okay, and we have H's at the other side. Whoopsie daisy, that's my 6 minutes up, so we've nearly got to finish the video. And we have H's on everything else, and that's where the 12 H's here come from. But if I were to describe what's in this molecule, I'd have to say, well, how many carbons? There's 6 carbons. How many hydrogens? There's 12. How many oxygens? There's 6. So the molecular formula of glucose is C6H12O6. Similarly, if I looked at water, what does that mean? It means there's 2 hydrogen atoms and 1 oxygen atom in the molecule. But these are molecules, okay? So a molecular formula tells us what's in the molecule, all right? Specifically, what type of atoms and how many there are in the molecule. An empirical formula tells us the ratio in the crystal. Okay, hope that makes sense between ionic and covalent, ionic, which use empirical formula, and covalent compounds, which use molecular formula. All right, take care.